13.8 billion years ago. Everything you see, everything you know, everything that has ever existed was smaller than a grain of sand. In the next 10 minutes, we'll witness the most incredible story ever told. The birth of stars, the forging of elements, the emergence of life, and the rise of consciousness itself. From absolute nothingness to the vast cosmos that surrounds us today. This is the complete history of our universe, and it's more extraordinary than any science fiction you've ever imagined. Are you ready to travel through time itself? It begins in absolute darkness. No space, no time, no matter. Just pure potential energy compressed into a point smaller than anything you can imagine. Then, in an instant that defies all logic, the Big Bang erupts. But this isn't an explosion into space. This is the creation of space itself. Time begins its relentless march forward. In the first trillionth of a second, our universe expands faster than light, inflating from subatomic to astronomical in size. At 1 second old, the universe is 1 trillion degrees, too hot for even atoms to exist. Only fundamental particles dance in this cosmic soup, protons, neutrons, electrons, all racing through expanding space at incredible speeds. The temperature is so extreme that matter exists only as plasma, a chaotic sea of subatomic particles. Light cannot travel freely because it's constantly absorbed and re-emitted by charged particles. The universe is opaque, glowing white-hot like the inside of a star. For 380,000 years, the universe remains this way, an impenetrable fog of charged particles. But as it expands, it cools. When temperatures drop to about 3,000 degrees, something magical happens. Electrons finally slow down enough to be captured by atomic nuclei. The first atoms form, mostly hydrogen and helium. Suddenly, the universe becomes transparent. Light can finally travel freely across space, and what we call the cosmic microwave background radiation is released. But with no stars yet burning, the universe enters what scientists call the cosmic dark age. It's a cold, dark place filled with invisible hydrogen and helium gas, waiting for the next chapter to begin. For 100 million years, the universe drifts in darkness. But gravity never rests. Slowly, invisibly, it pulls hydrogen and helium together into vast clouds. These aren't just any clouds, they're the nurseries of the first stars. As these primordial gas clouds collapse under their own gravity, they heat up. When they reach critical mass and temperature, nuclear fusion ignites. The first stars blaze to life, not like our sun, but as massive giants burning 100 times brighter and thousands of times more massive. These stellar titans are the universe's first light sources, but they live fast and die spectacularly. In just a few million years, they exhaust their nuclear fuel and explode as supernovas, the most violent explosions the universe has ever seen. But here's the crucial part. Inside these massive stars, nuclear fusion creates the first heavy elements the universe has ever known: carbon, oxygen, silicon, iron. The building blocks of planets and life itself are forged in these stellar furnaces. When the stars explode, they scatter these precious elements across space. These supernova explosions don't just create elements, they trigger waves of new star formation. The shock waves compress nearby gas clouds, causing them to collapse and form new stars. Gravity begins pulling stars together into the first galaxies, vast islands of light in an ocean of darkness. Before we continue this incredible cosmic journey, hit that like button if you're amazed by how we went from absolute nothing to the first galaxies in just a few 100 million years. And let me know in the comments, what do you think was the most crucial moment so far? The Big Bang itself, or the death of the first stars that created the elements we're made of? Your thoughts might surprise you. Fast forward 9 billion years into our cosmic story. In a quiet spiral arm of a medium-sized galaxy, something extraordinary is about to happen. A cloud of gas and dust, now enriched with the ashes of countless dead stars, begins to collapse under its own gravity. At the center of this collapsing cloud, temperatures and pressures rise until nuclear fusion ignites. Our sun is born. But this isn't just the birth of a star, it's the beginning of our solar system. Around the newborn sun, a flat disk of leftover material swirls in orbit. Over millions of years, dust grains stick together, forming pebbles, then boulders, then planetesimals. Through countless collisions, the planets slowly take shape. Rocky worlds form in the inner regions where it's hot. Gas giants accumulate in the outer reaches where it's cold enough for ice and gas to condense. Earth emerges as a molten hellscape, constantly bombarded by asteroids and comets. The surface is a sea of lava, and the atmosphere is a toxic mix of methane and ammonia. This is hardly the blue marble we know today. Then, 4.5 billion years ago, catastrophe strikes. A Mars-sized object called Theia smashes into Earth with unimaginable force. The collision nearly destroys our planet, melting its entire surface and ejecting massive amounts of debris into space. But from this cosmic disaster comes unexpected fortune. The debris slowly coalesces to form the Moon. This isn't just any satellite. The Moon will prove crucial for life. It stabilizes Earth's rotation, preventing wild climate swings. It creates tides that may have helped life emerge from the oceans. Gradually, Earth begins to cool. Water vapor in the atmosphere condenses and falls as rain. Rain that lasts for millions of years, filling the first oceans. But this is still an alien world. There's no oxygen in the atmosphere, no ozone layer to protect against radiation, and certainly no life. The stage is set for the greatest miracle in our planet's history. $3.8 billion years ago, in the warm, shallow seas of early Earth, the impossible happens. Somehow, somewhere, chemistry becomes biology. We still don't know exactly how, but non-living molecules organize themselves into the first living cells. It's the greatest mystery and the most important moment in our planet's history. These first life forms are incredibly simple, just single-celled bacteria. But they're about to change everything. For over 1 billion years, they dominate the planet, slowly evolving and adapting to every environment imaginable. Then, around 2.5 billion years ago, some bacteria develop a revolutionary new ability: photosynthesis. They learn to harvest energy directly from sunlight, using it to convert carbon dioxide and water into food. As a byproduct of this process, they release oxygen into the atmosphere. But here's the twist. Oxygen is actually toxic to most early life forms. This oxygen release triggers the first mass extinction event in Earth's history, wiping out countless species that can't adapt to the changing atmosphere. Scientists call this the Great Oxidation Event. Yet life, as always, finds a way. Some organisms learn to use oxygen for energy, making their metabolism incredibly more efficient. This breakthrough allows for the evolution of complex cells with specialized internal structures. These eukaryotic cells can grow much larger and more sophisticated than their bacterial ancestors. Around 1 billion years ago, the next miracle occurs: multicellular life. Single cells begin cooperating, forming colonies, then true multicellular organisms. Life experiments with countless forms and shapes. 540 million years ago comes the Cambrian explosion, life's greatest creative burst. In just 20 million years, most major animal groups appear in the fossil record. Eyes evolve independently dozens of times. Shells, claws, and complex predator-prey relationships emerge. The first complex ecosystems flourish in ancient seas. Life doesn't stay in the oceans. Plants colonize the land, creating the first forests. Animals follow, adapting to terrestrial life. For hundreds of millions of years, giant reptiles rule the Earth, the age of dinosaurs, until 66 million years ago, when an asteroid impact changes everything, clearing the stage for mammals to diversify and eventually for us. In the last 7 million years, barely a blink in cosmic time, something unprecedented happens in Africa. Apes begin walking upright, their brains start growing larger, and for the first time in Earth's history, consciousness awakens. Our earliest human ancestors develop tools, language, and the ability to think symbolically. They create art, bury their dead with ceremony, and begin to wonder about their place in the universe. Modern humans emerged just 300,000 years ago. We spread across the globe, adapting to every environment from frozen tundra to scorching deserts. We developed agriculture just 10,000 years ago, allowing us to build permanent settlements and complex civilizations. In the last few centuries, our progress accelerates exponentially. We split the atom, cure diseases, walk on the moon, and send robotic explorers to the edges of our solar system. We peer deep into space with powerful telescopes, discovering thousands of planets orbiting other stars. And now, through science, we've uncovered our cosmic story. We've learned that we're made of star stuff, literally. The carbon in our bodies, the oxygen we breathe, the iron in our blood. All were forged in the nuclear furnaces of massive stars billions of years ago. We stand at a unique moment in cosmic history. We're the universe becoming aware of itself, asking questions about its own origins and destiny. From a tiny point of infinite density to galaxies, stars, planets, and conscious beings, this is our story. This is the history of everything, and you, incredibly, are part of it. The next chapter of the universe's story is being written right now, and for the first time in 13.8 billion years, conscious beings get to help write it. What will we discover next? What mysteries will we solve? The greatest adventure in the history of the cosmos is just beginning.